Okay, so we're back and now we want to talk about what is average velocity and what is average acceleration. So we're going to begin with what is average velocity. Now, for the moment, I am going to use the terms speed and velocity as though they're the same thing. Now, we're going to find out that later that that is not true, that there is a difference between the speed of an object and the velocity of an object. But for right now, we don't need to worry about that. So, as far as I'm concerned, I'm going to say that the speed of an object is the same thing as the velocity of an object. And we're going to abbreviate speed or velocity with the letter v. So, lowercase v for velocity. And so let's think about in your car, you have a speedometer. And so what does the speedometer measure? Okay, it's going to measure your speed. What are the units on your speedometer? Well, here in the United States, we might use mph, miles per hour. So this stands for miles per hour. But if you're from anywhere else in the world, you're probably going to use metric units. And so instead of miles per hour, you're probably going to use kilometers per hour. And so what does it mean to say that you're going at, let's say, 60 kilometers per hour? Well, that means that in 1 hour, you could travel 60 kilometers. So just by looking at the units, you can see that the formula for speed is going to have something to do with distance, and then it's going to have something to do with time. So our formula for average speed is it's going to be the distance you travel, r, divided by the amount of time it's going to take you to do that in. So that we're going to say that your average velocity is going to be equal to distance divided by time. Now, why do I say average velocity? So here in Missouri, we have very hilly roads. And so let's say that we're going to be going from my hometown, Springfield, Missouri, down to Branson, Missouri. And so when you go down to Branson, you will notice that it's kind of like this. There's hills all over the place. And so let's say that the distance from Springfield to Branson, let's say is 40 miles. So I'm just going to estimate that. So let's just say that it's 40 miles, and then let's say that it takes you an hour to get down there. So then we would take the distance is 40 miles divided by 1 hour. So we would be traveling at 40 divided by 1 is 40 miles per hour. Okay, but that's not your real speed. So that's your average speed averaged out over the entire trip. So your actual speed, you might be going slower when you're going up some of these hills, and then you might be going faster when you're going back down the hills. So that your actual speed is going to change, but your average speed is averaged out over the whole trip. So for right now, we're just talking about what your average speed is, and then later we're going to expand this definition to talk about what about your instantaneous speed. So let's look at the units for this. The official metric unit for distance is the meter. And then the official metric unit for time is going to be the second. So therefore, the official metric units for speed or velocity are going to be meters per second. So here's a sample problem. If a car travels 10 meters in 2 seconds, what's its average speed? Okay, so anytime that we do a math problem, we always want to write down what we're given and what we're looking for. So you would actually start out this thing by writing down over here that you've got your 10 meters. That was given in the problem. You were given 2 seconds, and then you're looking for something. So just put down a question mark for that. And now look at the units. So meters is a unit of distance, and then the symbol that I use for distance is going to be the letter R. This is in seconds, and so the official metric unit seconds goes with time, and that's going to be the lowercase t. Notice that I put a hook on it because you don't want to mistake that for a plus symbol. So I always like to put a hook on the end of my t's. And then the question mark, what are we looking for? Well, it says, what is its average speed? So we're going to be looking for v. Okay, then the next thing is, what formula do we know that has an r, a t, and a v in it? And so that's the one that we just showed you. So that's going to be equation 3.1. And so we're going to write that formula down. Velocity is equal to distance divided by time. Plug in the distance, plug in the time, and you get the number 5. So then don't forget to put the unit on it. So the official metric unit for speed is going to be meters per second. So our answer is 5 meters per second. Here's another one. If a bike is traveling at 7 meters per second, how far can it go in 10 seconds? So again, we're going to write down what we're given. So we were given the speed. Remember, if it doesn't actually say the word speed, look at the units. It said 7 meters per second. Meters per second is a unit of speed. And then time is going to be the 10 seconds. And then we're looking for the distance. So we're going to write down what we're, the formula, which is going to be distance divided by time. And then plug in our numbers. And then solve it for the letter R this time. And so R will turn out to be 7 times 10, which is going to be 70. And then it's a distance, so the official metric unit is going to be the meter. So that we have the distance it's going to travel is going to be 70 meters. By the way, you notice that what I did was I plugged in the numbers and then I rearranged it. So you can take the formula with all the letters, rearrange that first, and then put the numbers into it. And so it doesn't make too much of a difference which way that you go when you do that. So here are some typical speeds. So you'll notice that some speeds are very slow, and then other speeds are very, very fast. Okay, let's take a break, and when we come back, we will talk about the concept of acceleration.